Hello, in this video we're going to take a look at taking the derivative of some basic exponential functions. So first of all, an exponential function is where you have a constant number in the base and you have a variable in the exponent, as we see at the two examples on the screen. When we take the derivative of an exponential function, in general, if we have the base a with an x in the exponent, the derivative of that function is going to be a to the x times the natural log of a. If that base happens to be the natural exponential e, then the derivative of e to the x is going to be e to the x times the natural log of e, but the natural log of e is just 1, and so the derivative of e to the x is just e to the x. Now you see a lot of exponential functions that have more than just a single x in that exponent, and so there we need to involve the chain rule. So if we have, in general, a base a raised to some function of x in the exponent, that derivative is going to be a raised to that function times the natural log of a times the derivative of that exponent. So we'll employ the chain rule there. All right, so let's look at these two examples. We have y equals e to the negative 4x plus 3. So our base here is e, so our derivative is going to be that same exponential, e to the negative 4x plus 3, times the natural log of e, which is 1, times the derivative of that exponent negative 4x plus 3, that derivative is going to be negative 4. So normally we see that coefficient out front, so negative 4e to the negative 4x plus 3 would be the version we would typically see that one in. All right, our next example, we have y equals 8 to the 2x squared minus 1. Okay, here our base is not that natural exponential e, and so we are going to involve the natural log of the base. But first, it's just that same exponential. Then we need to multiply by the natural log of base. And then since that exponent was something more than just an x by itself, we need to multiply by the derivative of the exponent. 2x squared minus 1, derivative is 4x. And because of order of operations, this natural log is a package deal. That exponential is a package deal. Really, the only thing we can do here, just like in the previous example, is to shuffle things around and write it in a different order. It does not simplify anything, but I like to always have my natural log at the end, so there's no question what is actually in that natural log. But what I did in this last step is not really simplifying anything. All right, I'll see you guys next time.